Hello and welcome along to a video about some of the weather systems that affect the British Isles. In particular, we're going to take a look at depressions in this video. Before we do that, we need to set a little bit of context on the air masses that affect the British Isles. What is an air mass? An air mass is a large body of air that has certain characteristics of temperature and humidity or moisture, water vapor. On the basis of temperature, it can come from tropical regions and it'll be warm, or it can come from polar regions and it'll be cold. On the basis of humidity, if it comes over continents, it'll be dry. If it comes over the sea, maritime areas, it'll be moist. So this one is coming from the north. So is it tropical or polar? Yeah, it's polar. It's coming over the sea, continental or maritime? Yeah, it's maritime. So this is your polar maritime air mass. This one is coming over the sea, continental or maritime? Yeah, maritime. And it's coming from the south, from the tropics, so it's tropical maritime, or TM. Polar maritime, tropical maritime. Those are the two main air masses that affect the British Isles. However, you can also get one coming from the polar regions here to the east. They come over the continent, so this is going to be your polar continental air mass, and in the winter that tends to bring colder weather conditions to us. And then the least common air mass, the one that comes from the tropics, the Sahara Desert, and over the continent, it's warm, it's dry, it's the one that we get least. It's the tropical continental. PM, TM, PC and TC. Just one thing quickly before we move on. Polar continental air mass is coming from the continents. And if you remember from the last section on continentality, in the winter the land cools down very, very quickly. So it's very cold. So the polar continental air mass brings very cold air towards us, the beast from the east. However, during the summer, the land heats up very quickly. So, rather confusingly, the polar continental air mass in the summer actually brings very warm weather. Okay, I know it's called polar, but remember it's got to do with the continentality, and the land heats up quickly in the summer, bringing the warm air towards us. Now, the two air masses that are going to be most relevant to what we'll look at in the depression are the PM and the TM. So let's jump into the weather systems affecting the British Isles. Now, I have to say, I feel sorry for weather forecasters. Weather forecasters get a little bit criticism from time to time about not really knowing what the weather's going to be like. Actually, our ability to forecast the weather is pretty good, all things considered. And part of the reason for that is because we recognize that there are particular systems that bring different types of weather to the UK. So he's right to be looking very happy and confident there because of what we know of these weather systems. And if you know what weather system is coming, you have a good idea of what the weather that it will bring will be. And there are two of them, two main weather systems that affect the British Isles: depressions and anticyclones. This is a list of the features. You can pause the video if you like and have a look at those. The one thing to say is it's another nice one of those little sections in geography where once you learn one half, the other half is just the opposite. So depressions, low pressure, anticyclones, high pressure, etc. We'll pick these up as we go through the video anyway. Okay, let's go to the first of our weather systems, and that is a depression. I'm going to teach you a little bit about how they form. This isn't on the spec, and you're not going to get a question in this in the exam, but I think it just is one of those occasions when it helps you to understand the things that are on the spec and you do know. So this is a map showing the wind direction of the North Atlantic. There's the British Isles, and I want you to focus here over towards the west because this is a depression. I want you to look this wind here coming from the southwest, so it's tropical over the ocean, maritime, TM. This one coming from the northwest, polar, maritime, it's PM. So here's the wind direction, the TM and the PM. I want you to notice here when these two air masses meet, they don't mix. There's a very definite line that forms between them. And this line that forms between them when they meet but don't mix is called a front. So the formation of a depression, this is your warm air mass from the south. Everything below the front, everything to the south of the front is Tm, it's warm. Everything to the north of the front is Pm, it is colder. And that's that front that forms between them. Now over time the winds will organize themselves into a rotation around the center of the low pressure of the depression, that everything to the south of the front is Tm, everything to the north of the front is Pm. And there is that rotation. There it is. Everything to the south of the front is Tm. Everything to the north of the front is Pm. Hold that in mind because it will be helpful to you as we go through. Okay, here is a plan view of our depression. It looks a little bit complicated, but there's our Pm air there and our Tm air, and there's the front that forms between them. Whenever they meet, they don't mix and the front forms. This is called a cold front with the blue triangles. This is called a warm front. And this one here is called an occluded front. You kind of just need to know that that exists. We don't really need to know anything more about that at GCSE. So let's imagine now that we're looking at this at an angle. We've sent a helicopter drone up high into the sky and we're looking at an angle. And we're going to kind of slice through it. Or if you want to imagine this is like a depression's weather system cake. And on the top of it we've got this lovely little icing. If we cut down into the cake, what does it look like? Because these depressions are three-dimensional features. And if we slice down through this is what we're seeing. This is the plan view at the top. This is the cross-section or sideways view at the side. There's our front, there, warm front. This is our warm front here. This is our cold front. This is our cold front here. And here's our Pm air, Pm, Tm, Tm, Pm, and Pm. Finally, for now, I'm going to show you some of the names of the different parts of the depressions. Depressions approach from the west. So the first part that we meet is this bit here, before the warm front. Then the warm front. Then the Tm air is called the warm sector. Then we have the cold front. And behind the cold front back into the Pm air again. This structure of the depression is something that you need to know very, very well. Right, one final thing before we go on to take a look at the weather that you get with a depression, and that's these other lines in the map called isobars. These are lines joining all points of equal air pressure. And in a depression, you generally have the isobars that are very close together. In the anticyclone, the other type of weather system, the isobars are far apart. So a depression has what's called a steep pressure gradient. Think of contour lines. They're lines that join all points of equal height. And just like if you've got the contour lines close together, you're going to have a very steep slope. When you've got the isobars close together, you've got a steep pressure gradient. So which one of these is going to have a faster wind? Well, imagine if you've got a steep slope and you throw a ball down the side of it, it's going to roll down very fast. A more gentle slope, the ball is going to go much slower. So this is the one that has the steep pressure gradient and the strong winds. This is the gentle pressure gradient and the lighter winds. All right, with that context set, let's go in and take a look at the weather that you get in a depression. Now, I'm going to show you in a moment the overall table that you've got to learn, and it's going to feel like there's a lot there. And let me tell you, the worst way to do this is to sit down and try and learn it off by heart. It's going to be tough to get that into your head. So I'm going to teach it to you based on certain principles. The best way to learn the weather associated with the passage of a depression is to learn the principles, make sure you understand them, and use them to help you understand the content in the table. Then in the exam, if you forget any part of the table, as long as you remember the principles, you should be able to work it out. Here are the principles. Okay. Principle number 1. Air masses explain temperature. Now that's not going to come as a surprise to you, is it? Tropical maritime is warm. Polar maritime is cold. The clue is in the name. Principle number 2. The fronts is where you get the cloud and where you get the rain, because you're getting the air rising there at the fronts. More on that in a moment. Principle number 3, the air circulates in an anti-clockwise direction around a depression, and that's going to help us with our wind direction. Okay, so we're going to take those principles into the weather and help us to understand them. So here we'll take a wee look again at the cross-section through the depression. There we are, before the warm front, the warm sector, the cold front, and behind the cold front. Okay, and this is, the scary table that you're going to have to learn, but please don't panic just yet. The principles in yellow there are going to really help you with this. Okay, principle number 1, air masses explain temperature. So the colour up here I'm hoping will help you to just get some of this in your head, to remember it. Whatever, PM, TM, PM. Remember, we've met that earlier. PM, TM, PM. Polar maritime, coming from the northwest, is cold. TM, tropical maritime, coming from the southwest, is warmer. So, there's our PM air mass before the warm front, TM air mass in the warm sector, PM air mass behind the cold front. So what do you reckon the temperatures are going to be? Cool, mild, cold. The air masses help to explain the temperature. Get that colour scheme locked in your head. It's going to help you to remember that. Right, principle number 2, the air rises at the fronts, and that's where you get cloud and rain. As we saw when we were looking at how altitude affects the amount of precipitation, we came across this. As air rises, it cools. Cold air can't hold as much water vapour, so it becomes saturated, leading to the process of condensation, the formation of cloud, and the possibility of precipitation. It's exactly what we saw when we looked at altitude. The air meets the hills, it's forced to rise. As it rises, it cools. Cold air can't hold as much water vapour, it becomes saturated, leading to the process of condensation, formation of cloud, and the possibility of precipitation. When air rises, it cools and condenses cloud and rain. When air rises. Okay, question. Where is air rising in a depression? Well, it's rising as the warm air at the warm front rises over the cold air, and at the cold front, the cold air is undercutting the warm air. So there's the warm air rising at the warm front, rises, cools, condenses to form cloud. Cold air undercutting at the cold front, rises, cools, condenses to form cloud. So you're getting the air rising at the fronts. As it rises, the air cools, cold air can't hold as much water vapour, it becomes saturated, leading to condensation, formation of cloud, and the possibility of precipitation. So the principle you can see here, air rises at the fronts, giving cloud and rain. So here's our cloud and our rain. We're first of all getting, as the warm front appears, some cirrus cloud. You're not going to get any rain with the cirrus cloud. Then you're going to get nimbostratus cloud, which is going to be drizzle going into rain as the warm front approaches. Then when you get into the warm sector, you're not going to get any cloud or rain because you don't have a front there. Then when you come to the cold front, there's the clues in the name, there rises, cools and condenses to form cumulonimbus clouds, which give you the gloriously heavy rain. And after the cold front itself, you will have your sunshine and showers weather, courtesy of those cumulus clouds. So the air rises at the fronts, so you're getting the cloud forming there and the precipitation at the fronts. That's your second principle. Talking of clouds, we'll just take a look at what the cloud pattern looks like in a satellite image. I've sketched this out. There is our warm front, our warm sector, our cold front, and there's our wee occluded front hooking round there at the top. There's the centre of the low pressure. What does a cloud pattern look like here? It's got this very characteristic pattern. You can see the looping pattern of the clouds that correspond very closely with where you get the fronts, and that is very much the pattern of cloud that you will get in a depression. So there's our cirrus cloud as the warm front begins to approach. There's the nimbostratus cloud at the warm front. Warm sector, you're not getting much by way of any cloud. cumulonimbus cloud at the cold front, and then there's your sunshine and showers cumulus cloud after the cold front itself. Okay, principle 1, air masses explain temperature. Principle 2, air rises at the fronts, rises, cools and condenses, forming cloud and rain. The final principle is air circulates in an anti-clockwise direction around a depression, and that helps to explain the changes in the wind direction that we get as the depression moves over. So initially in Belfast we're going to get southwest wind, then as we move into the warm sector it's going to be a westerly wind, and as we go behind the cold front it's going to be northwesterly wind. That's anti-clockwise circulation that means as the depression passes over, the wind direction changes depending on which part of the depression that we're in. Southwest, west, and then northwest. So when we're ahead of the warm front, it's southwest. The warm sector, it's west. And after the cold front, it's northwest. Here's the content for the table you need to learn. The air circulates in anti-clockwise direction. So before the warm front, it's southwest. In the warm sector, it's west. After the cold front, it's northwest. Okay, that's it. Let's see if you can test yourself. Do you remember what those blanks are? Okay, so what is it that explains temperature? It is air masses. Yeah, good. Second principle, air rises where? At the fronts. As air rises, it cools. Cold air can't hold as much water vapor. It becomes saturated, leading to the process of condensation, cloud, and rain. Principle number 3, which direction does air circulate around a depression? Circulates anti-clockwise, so that helps us to explain the wind. Okay, so how much of this can you recall? Would you pause the video here and have a go and see how much of that you can recall? Test yourself in this based on those principles. And as you do so, I think you'll find that a lot of this will stick. Certainly there's learning in this, but this is definitely the way for you to try and get this in your head most clearly. So that's our weather system of depression. In the next video, we'll go on and take a look at the weather system of an anticyclones.